Yarn working model view. In previous slide, we saw what a cluster comprises of. We also saw that in case of Yarn, master process is the resource manager and worker process is the node manager. Let's look at how Yarn functions. This is our cluster. Resource manager as the master process running on master node and node managers as the worker processes running on the worker nodes. Each node manager tracks its own local resources, virtual cores and memory. The number of virtual cores is generally recommended to be kept as the number of physical cores actually there in the machine. And memory is the RAM that the node has. So first node has 4 cores and 8 GB of RAM. The next one has 4 cores and 16 GB of RAM. And the one remaining has 2 cores and 8 GB of RAM. The resource configuration from each node manager in the cluster is then communicated to resource manager. In this case, if we see, the total count for resources we get is total 10 virtual cores and 32 GB of RAM. Client runs an application program which is made up of one or more tasks. The application starts and then talks to resource manager. Resource manager makes a single container request on the behalf of the application. The container is allocated on the cluster. To start any process in the container first has to request for the virtual cores and memory from the node manager. Here, in this case, to start application, container has requested 2 virtual cores and 4 GB of RAM. Once the requested resources are granted to container by the node manager, container holds these resources and utilizes them to start application master. Application master is nothing but a piece of code which helps coordinate tasks on Yarn cluster. Application master requests subsequent containers from resource manager to run tasks for the application. So we have containers to run tasks now. For a task, container has requested 3 virtual cores and 4 GB of RAM, whereas the other one has requested 1 virtual core and 2 GB of RAM from the resources available with the node manager. Once the containers hold these resources, tasks are started. Keep in mind that application master coordinates these tasks. An application program is made up of many such tasks. When the started tasks are completed, containers release the resources that they had acquired from node manager. Application master exits and the only remaining container releases its holded resources too. We got a hook of what are the Yarn processes and the flow of these processes. Now let's see how Spark framework sits on the top of Yarn. To maintain the flow, we will repeat the steps which involved launch of application and container request. To manage Spark job flow and schedule tasks, Spark relies on Spark driver process. Once the containers are allocated, node managers start the executor processes. The Spark tasks are then scheduled on this executor process by Spark driver. So what is the benefit of running executor process? The executor process keeps on running even if no jobs are running. Whereas in MapReduce framework, container starts up a new JVM process to start a task. This approach of Spark framework speeds up the task startup time as well as in-memory data processing.